Learning the basics is just the first step to master mountaineering skills. While mountains are among the most beautiful areas on Earth, they can also be the most unforgiving. To safely accomplish your mission and to be an asset to your team, you must grow in your knowledge and respect for this challenging environment. This video is intended to assist you in developing the skills needed to operate successfully in the mountain environment. To do that, we will examine proper climbing techniques and rappelling techniques. Proper climbing techniques. As many climbers have learned the hard way, mountains, despite their beauty, are dangerous. Safety must be your first priority, and common sense will be your most valuable asset. Carefully check all your equipment before heading out. Always wear your helmet and never wear jewelry. Take your time to plan your routes and moves before starting to climb into a no-up, no-down situation. Correctly use protection devices and avoid runouts. Beware of gear and band slings dangling too low on your harness. Check holds before using them. Don't jump or lunge for holds. Avoid dislodging rocks, but if you do, or if danger exists for climbers below, call out rock. To climb safely, you must assess the difficulty of your climb before beginning. To grade climbs, the Army uses the Yosemite Decimal System, or YDS. The YDS classifies climbs from grade 1A, hiking trail that could take several hours to complete, to a grade 5.14D. Along with these ratings, you can see an R, which means there is runout in the route. You can also see an X, which means that there is such runout that a fall will result in hitting the ground. Beyond this, there is also aid climbing ratings from A0 to A6. The best way to learn the YDS is through experience. When you train, always ask your instructor the grade of the climb, study all the climbs in the area, and ask more experienced climbers for examples. To climb successfully, climb with your head and your eyes. Think and see before you do. Climb relaxed. Tense muscles tire easily, and climb with your legs. Push, don't pull yourself up the mountain. Just as a ball player whose body is out of position can't make the play, if you are out of position, you won't be able to make the climb. When climbing, maintain 3 points of contact with the rock. Spread your hands and feet for a more solid platform. Lean your upper body away from the rock face to create better contact between your boots or shoes and the rock face. Use your arms and hands for balance. Move smoothly. Fast and jerky movements put more weight on contact points and waste energy. Avoid flailing your legs until they stick. Look down to find a spot for your feet. When gripping with your hands, try to place as much skin on the rock as possible. There are several types of handholds you will use. Push holds, also called mantling, are pushed down upon. They keep your arms low, which is good, but are difficult to maintain if you slip. It's best to use a push hold in combination with a pull hold. Pull holds are pulled down upon. While the easiest to use, they are also the most likely to cause rock to break away. Friction holds are quite weak, depending solely on the friction of hands or feet against a fairly smooth surface. Use only as an intermediate hold on your way to a better hold. Jam holds involve forcing an extremity into a crack. You might jam an arm into a crack and then make a fist to secure it. Be sure that you will be able to remove the limb after jamming it in place. Pressure holds use the knuckles, fingertips, or hands to apply pressure. Pinch holds are where the fingertips pinch the holes, usually in a vertical position. Foot positioning is critical. Place as much of your sole on rock as possible. Keep your toes pointed outward. Attempt to stay on the big toe and keep the heel level. Traverse using the inside of the sole. Jams that you do with your feet are the toe jam, where the contact area is the toe of the boot or shoe, the foot jam, and the leg jam. Crack systems in the rock provide the easiest natural route for a climb. You can readily use a variety of holds. They also provide many accessible points for artificial protection placement. Crack systems can be vertical or horizontal. To climb a narrow chimney, create cross pressure between your back and your feet. Raise your back using both hands for support. Then, one at a time, lift your feet. In a wide chimney, spread your feet and hands, one on each side. Climb by alternately moving hands and feet. The technique for climbing a dihedral or open book is similar to that used in the chimney. Align your body facing the dihedral. This is called stemming. Cross pressure is exerted on your hands and feet, but the back is not used. Proper layback techniques begin with using any grip, over or underhand, that will allow you to lay back on outstretched arms. Be sure that your feet are high enough to create counterpressure for your hands. Then move higher by alternately moving your hands and feet. Left foot, right hand, right foot, left hand. When climbing down, face outward if it is easy. Face sideways where it is too difficult to face out. Face in toward the rock where the climb is most difficult. Always use the lowest possible hand and footholds. The proper placement of protection is crucial in holding a fall. When starting out, you should have two good placements between the lead climber and the ground. This is to prevent bottoming out in the event of a fall. Keep following climbers in mind. In a long traverse, place protection to prevent a following climber from a pendulum fall. Long runners will be used on projecting rock points around trees and through rock sandowers. Chocks, such as walnuts, rocks, hexcentrics, half-moons, and stoppers, are to be used in crevices appropriate for their size and design. Place these carefully in the direction of pull. Give each placement a slight tug to keep it from falling out before climbing on. Pitons must be placed in good, solid rock. Test the rock for soundness by striking it with the hammer. If it sounds hollow or loose, choose another spot. Avoid, if possible, soft, rotten rock and sandstone. Choose the right size piton for the crack. About 1/2 the piton should slip into the crack before hammering. As you pound the piton, you should hear an increasingly higher pitched sound. Spring-loaded camming devices, or SLCDs, such as Friends, Camelots, Quad Cams, Low Balls, and Aliens, should be placed so that the direction of the pull is along the long axis. The cams should be opened up to a minimum of 45 degrees and not fully retracted. In other words, in the middle of their mechanical range of motion. If less than 45 degrees, they may not hold. If fully retracted, it may walk into the crack further and you'll never retrieve it. Don't allow the shaft of a rigid SLCD to be levered against the rock edge. This could cause the shaft to break if there is a fall. Keep the shaft in the direction of a possible fall. The last climber will remove the artificial protection using a chalk pick if needed. A piton hammer and sling will extract most pitons. Belaying is the method a belayer uses to be ready to slow and stop the fall of another climber with the rope. Belay points must be strong enough to hold the fall. They will be aimed in the expected direction of the load caused by a fall, up or down. If it is the first point on the ground, load will be up. If the belay point is the last on the climb, then the load will be down only. If a fall occurs, the point must hold the belayer in place. If using a body belay, belaying from the harness, the belayer must be tied to the anchor. When lead climbing, belay point anchor systems will be constructed with a minimum of 3 anchor points. The location of a belay is very important. On the ground, it must be near a good anchor and permit the belayer to get close to the rock wall. On the rock wall, the belay point must permit the climber to construct a solid anchor system. Belaying requires undivided attention, so a location with a ledge, large holds, or a horizontal crack that permits the belayer to sit or brace his feet is much more comfortable than a hanging belay. Because a belayer is restricted in his movement, he is vulnerable to falling debris. It is much safer and faster to stop short of a full rope length at a good belay site than to push on and struggle at a bad location. Having chosen a belay site, first anchor yourself to at least one anchor before building the anchor system. This will guarantee your safety while you construct the anchor system, and you can then incorporate this anchor into the system. Always consider the potential load and the direction or directions that it will come from before building the anchor. On the ground, load is only upward, and at the top, only downward. Load at intermediate belay points will be in both. An anchor at the end or beginning of a traverse must be omnidirectional. SRENE stands for solid, redundant, equalized, and non-extending. Use this acronym to remember the four facets of an anchor system. S, solid, all individual anchor points, be they a tree or a single piece of protection, must be solid before they are included in an anchor system. A solid anchor system must be properly placed, and you must have no doubt of its ability to hold a fall. An anchor system with two solid pieces and a weak one is in essence only a two-point anchor system. R, redundant. Redundancy is achieved when any one part of an anchor can fail without complete system failure. Build all belay anchor systems to be as redundant as possible with the materials on hand. E, equalized. The load should be equalized between all anchor points. When possible, a belay anchor system should be self-equalizing. The anchor system adjusts to more than one direction of load while still distributing the load equally among anchor points. NE, non-extending. The anchor system should be non-extending, meaning that should one point fail, the system will not elongate. Elongation will shock load the other points of the system. Shock loading will greatly increase the force applied to the remaining anchors, increasing the possibility of their failure. It is important to note that in order to get an equalized anchor, you must give up the non-elongation aspect. And inversely, if you incorporate the non-elongating, you will give up the equalizing aspect. When building an anchor system, make sure that all materials used meet the required specifications. In the equalizing or band sling configuration, the individual anchor points are clipped into a loop formed by either a band sling or cordelette. Put a half twist in the band sling or cordelette between each point. The half twists will be matched up in the direction of pull. Then insert an HMS carabiner through all loops. The belay device is attached to the same locking carabiner. This system has redundant protection, but only one sling or cord. It is self-equalizing. But if one anchor point fails, it will extend. The non-extending or cordelette configuration uses a cordelette formed into a loop by tying a double fisherman's knot in a 7 to 9 millimeter cord, 16 to 20 foot long. Each anchor point is clipped into the loop formed by the cordelette. The cordage is pulled down between each anchor point in the direction of load when matched with the lower portion. A figure-8 knot is then tied with these bites. If the cord is too long, extra wraps can be made when tying the figure-8. The belay device is attached to the loop formed in the figure-8 with the locking carabiner. If there will be upward pull, an additional anchor point may be clipped into the loop formed by the figure-8 knot. Your safety arm can be clipped into the portion of the cord above the figure-8 knot and between all the loops going up to each point. This area is referred to as the shelf. This system is redundant, equalized in one set direction, and non-extending. At times, you may want to belay positioned away from the anchor system. To do so, first attach a locking carabiner to the main attachment point of the anchor system, and another to the tie-in portion of your harness. Pass the climbing rope from yourself through the locking carabiner attached to the anchor system. Then tie it to the carabiner on your harness with a clove hitch. You are now tied to the anchor system. By adjusting the clove hitch, you can move to a better belay stand. The belay device is attached to the main attachment point of your harness. This system will use a great deal of rope. If rope is not available, tie the clove hitch directly into the anchor system with enough slack to reach the belay stand. When you are away from the anchor, be sure you're in direct line with the expected load and the anchor system. Finally, when building anchor systems, stick to the protection placement basics. Ensure rock is sound. Avoid sharp edges. Be sure trees are firmly rooted. Check all fixed protection. Ideally, all pieces of protection in an anchor system should have their direction of load directed toward the main attachment point of the anchor. When building the system, attempt to keep the angle created by your webbing or cordage below 90 degrees. Below 60 degrees is best. This will reduce the percentage of force applied to each piece of protection. While it is acceptable to attach the belay directly to your harness, it's preferred that the belay device is attached directly to the anchor system. In the event of a fall, the shock will be off the belayer, helping him maintain control of the belay. Belaying directly from the anchor will simplify rescue systems. Rappelling techniques. The rappelling anchor site must, like a belay anchor, be solid, redundant, equalizing, and non-extending. The site must be able to hold 3 times the weight of the rappeller and rope. There must be a safe area for rappellers to approach and hook in. Whether your anchor site is natural or man-made, be sure it is solid and can withstand a fall. If using a tree, brush, or a branch, be sure it is alive and well-rooted. If the tree is dead, be sure it is solid. Wrap the rope around the trunk of the tree as low as possible to keep the tree from being levered out. If using a boulder, be certain it is not teetering. Be aware that in alpine conditions, a boulder may be frozen in place and may loosen when weighted. Check before each use that the rope is in place and will hold in the direction of pull the entire time of use. To construct a rappelling site using a natural anchor and using one rope, place the middle of the rope over or around the anchor. Tie the ends with a figure 8 or overhand knot 18 to 20 inches up from the bottom of the rope. Throw the rope over the edge, ensuring the rope touches the ground. When using 2 ropes, first tie the ropes together with an overhand knot and place over or around the anchor. The overhand knot must be to one side of the anchor. Tie the rope together with a figure 8 or overhand knot 18 to 20 inches up from the bottom of the rope. Throw the rope over the edge. When you build a rappel site and are emplacing artificial protection, keep in mind what the direction of pull will be. To ensure even distribution of load, make the belay triangle self-equalizing with a band sling. However, if one point fails, the other points will be shock-loaded and you may not be able to remove the protection. In both natural or man-made sites, the rappeller must be able to easily reach the rope and begin rappelling at the anchor. Secure all rappellers with a band sling or sling rope onto a fixed line until they clip into the rappel device and can control the break end of the rope. The safety arm can then be removed. Use aluminum rappel rings in pairs. It is easier to pull rope down than a band sling, and the rings can be left behind. If rappelling because of emergency or weather, you may need all your protection to get down. Attempt to use natural anchors as much as possible. If rappelling to an unknown area and the end of the rope won't be seen, tie an overhand or figure 8 knot about 3 feet above the bottom knot. This will allow you to stand in the bottom knot, rest on the upper knot, and if needed, configured Prusix to ascend the rope. Butterfly coil the rope, starting at the tails. Coil the rope in one hand. Before you throw the rope, shout the warning, "Rope," to alert anyone below, then throw the rope over the edge. Throw using an up and out motion. If the walls are very steep and there are no loose rocks on your ledge to endanger anyone below, anchor the rope, then flake or backlay the rope onto the ledge. Then take 5 or 6 coils from the running end and throw. The rope will feed automatically from the pile. Every rappeller must use a safety backup as a brake, such as a Bachmann knot, a Klemheist, auto block, or a Prusik knot. The body rappel is to be used when time is short or in an emergency. The body rappel requires only an anchor and a rope. Face the anchor point and straddle the rope. pull the rope from behind and run it around either hip diagonally across the chest and back over the shoulder. Then run the rope to the brake hand, which is on the same side as the hip that the rope crosses. The right hip to the left shoulder to the right hand. Lead with the brake hand down and face slightly sideways. The hand nearest to the anchor is the guide hand. To brake, bring the brake hand toward the chest. Lean out at a sharp angle to the rock. Keep the legs spread well apart and relatively straight for lateral stability and the back straight to reduce friction. The modified body rappel is nothing more than using a Swiss seat with the body rappel. Run the rope through the carabiner, up over the non-brake hand shoulder, behind the back, and under the brake hand arm. The braking action is the same as the body rappel. This rappel is designed to relieve friction on the groin area. The hasty rappel is to be used on moderately steep or slippery slopes. It is very effective when carrying heavy rucksacks. To conduct a hasty rappel, face sideways to the anchor. Place the rope horizontally across the shoulders, wrapping the rope around the outstretched arms. The hand nearest to the anchor is the guide hand, and the other is the brake hand. To stop, bring the brake hand in front of the body, locking the rope. Don't use the hasty rappel on vertical or overhanging areas. In this video, we have looked at intermediate mountaineering skills, including proper climbing techniques and rappelling techniques. As your knowledge of and respect for the mountain environment grows, you will master these skills and be able to safely accomplish your mission.